Very good morning, friends. In this video, we are going to take the next step to the glycolysis. As we know, the product of the glycolysis is the two pyruvate molecules. Now, the two pyruvate molecules can enter into the three main reactions. The aerobic respiration we are going to see in this video, the anaerobic respiration and the fermentation. The anaerobic respiration and fermentation, I covered them in a separate video. You can also see it. So now the main one is the pyruvate oxidation, how pyruvate is converted into the 2-acetyl coenzyme. 2-acetyl coenzyme, don't confuse, isn't 2-acetyl coenzyme. It means there is a two molecules of acetyl coenzyme. That is the proper way to say this thing. There is a two molecules of acetyl coenzyme. So two pyruvate molecules is going to convert into the 2-acetyl coenzyme. Two molecules of acetyl coenzyme. So the glycolysis occur in the cytosol and the product we get is the two pyruvate molecules in the cytosols. But we know that the TCA cycles is the next step of the glycolysis is going to occur in the mitochondrial matrix. And the pyruvate oxidation is a link between the glycolysis and the TCA cycle. This is the important link, pyruvate oxidation. Or we can say that this is the intermediate between the glycolysis and the TCA cycle. Or the you can also know with the Krebs cycle or the many other names. So two pyruvate molecule cytosol is converted into the two molecules of acetyl coenzyme and two molecules of CO2 just exclude out. This reaction is take place in the mitochondrial matrix. Now the enzyme involved and what we get. The enzyme involved is not a single enzyme. First I want to clear it. There is a complex of enzyme involved. The complex includes the three enzymes mainly. We are going to take this in this diagram. You don't need to scare with this diagram because it's going to be much easier to understand. That is the overall reaction and it is the complete mechanism. It's important for you if you are preparing for the CSIR, ICMR or any a good level examination. So pyruvate dehydrogenase complex. Why I write complex? I said it. It is an group of enzymes. That's why the pyruvate dehydrogenase complex, three enzymes are involved in it. And the reaction occurring is the oxidative decarboxylation. Decarboxylation, you can see there, CO2, two molecules of CO2 is coming out, and the oxidative, the oxygen molecules is going to add there. So, two NAD positive. Be careful about a thing when you are in the biochemical pathways. In some books, some biochemical pathways are shown with the only one pyruvate molecules to make it simpler. But the actual product is the two pyruvate, and I am taking the complete product into the two molecules of acetyl coenzyme. In some books, you find that there is only pyruvate is given. So here only one NAD, one NADH, one molecules of CO2, and one molecule of acetyl coenzyme you get. They are also right because they are taking the one pyruvate molecules and the as we know the final product is the two pyruvate. That's why I'm taking the complete one, not trying to make any confusion. That's why I'm taking the whole product. So 2 NAD positive is converted into the 2 NADH. We are going to get it. So when we take the net product of the pyruvate oxidation is the 2 NADH. So when we change into its ATP, that is 2 into 2.5, that is the 5 ATP, we are going to get 5 ATP. Now still we take the simpler reaction, the complete reaction. Now we are going to take a look to the pyruvate dehydrogenase complex and the mechanism. First, let's come to the pyruvate dehydrogenase complex. What enzymes it contains, what coenzyme it contains, and what are the important points. There are three enzymes E1, E2, and E3. I mention it like this. The first enzyme is pyruvate dehydrogenase. Dehydrogenase means the extrusion oxidation is going to happen mainly. You can say that pyruvate dehydrogenase is there means there is an oxidation. And you know that oxidation is done by removal of hydrogen. addition of oxygen and also the electrons transfers. So pyruvate dehydrogenase is going to do the oxidation. And the most important things about the coenzymes, the pyruvate dehydrogenase enzyme is having the coenzyme is the TPP. It is right in the short form, that is the thiamine pyrophosphate. Thiamine pyrophosphate, when you think, I think you see my previous video of vitamins, it is vitamin B1. Vitamin B1 coenzyme is the thiamine pyrophosphate. I write it in the short form. Let's come to the next. Decarboxylation reaction is also going to there. E2. It's contain the coenzyme lipoic acid and the coenzyme A. First, let's talk about the coenzymes. Then we come to the enzyme. When we are talking about the lipoic acid, first I want to tell it is not an enzyme or not an vitamin of the vitamin B1, any of the vitamin, it is not there. So when you see any composition of any pharmaceutical formulation of vitamin B, you see that there are all the coenzymes in there, but you see that there is an lipoic acid is also there, which is not an vitamin coenzyme but is also included. The question arises why it is included in the vitamin B formulations. For example, I remember a brand name of the drug that is having the vitamin B, that is the Neurobean 40. Generally you see the ad on the TV, the Neurobean 40, it's a vitamin B complex formulation. Many of the syrups also comes, you see in these preparation lipoic acid is also included with the vitamin B coenzymes. So it's containing the lipoic acid, that is not an enzyme coenzyme. Coenzyme A, its relation with the vitamin B5 pantothenic acid, and the enzyme name is the dihydrolipoyl transacetylase. The name's telling you dihydrolipoyl means the lipoic acid is there. Transacetylase means there is a transfer of the acetyl group to the coenzyme A. This make you simpler these phenomena. If you taking care of these things, the pyruvate dehydrogenase is going to do the decarboxylation and the oxidation. Dihydrolipoyl transferase E2 containing the lipoic acid and CoA as a coenzyme is going to transfer the acetyl group to the coenzymes. Now to the third, E3, that is the dihydrolipoyl dehydrogenase. Same reaction is going to happen there. Means the oxidation is going there, dehydrogenase means hydrogen is getting out or oxygen is in. So dihydrolipoyl dehydrogenase. This makes you simple the reoxidized dihydroxylipomide you are going to see in there how it is reoxidizing. Now to come to the coenzyme, it is the NAD positive and the FAD positive. It is the vitamin B3, that is what niacin, and FAD positive. It is what vitamin B2, that is known as riboflavin. FAD and FMN there, so it is known as the riboflavin. Vitamin B2, so it is vitamin B3, vitamin B2, vitamin B5. It is not a vitamin coenzyme and it is vitamin B1. You have to remember this. The lipoic acid is the only thing. CSIR asked this question on the lipoic acid. So you have seen the enzymes. Pyruvate dehydrogenase as E1, dihydrolipoyl transacetylase as E2, and dihydrolipoyl dehydrogenase as E3. So let's come to the main pathway of the reactions. Now we are having the pyruvate. You have to take care of this. I am taking as in single molecules of pyruvate. Here are two molecules, so you have to take care of this thing. Okay, I will make it two at every place. So two pyruvate molecules is giving you, as you see that the two CO2 molecules is excluding out. Even this is the first step, As the CO2 molecules is removed out, the enzymes come in the action is the pyruvate dehydrogenase that is doing this action, and that the coenzyme thiamine pyrophosphate is going to attach to the compound formed after the two pyruvate molecules release the oxygen out, and that is the hydroxyethyl thiamine pyrophosphate. Decarboxylation is there and oxidation is also going to there. So as the pyruvate molecules release two molecules of CO2, the thiamine pyrophosphate is the coenzyme of the pyruvate dehydrogenase is going to bind with the compound that is forming after the release of CO2, that is the hydroxyethyl thiamine pyrophosphate. This is the first step. Still this is the first step. Even enzyme is involved. Now let's come to the second step. As we know, the second step and the second enzyme, dihydrolipoyl transacetylase. In this, there are two or three mechanisms are going to be done. First, to the thiamine pyrophosphate, lipoic acid is going to attach first with the acetyl coenzyme because it is going to transfer the acetyl group to the coenzyme A. It is having the coenzyme A and the lipoic acid, and the transfer reaction is done by this. So this is the second step. E2 enzyme is involved, hydroxyethyl thiamine pyrophosphate. In this, the acetyl coenzyme, the acetyl group is carried to the coenzyme by this enzyme and it is attached to the lipoic acid. From this molecule, the acetyl group, from this molecule, the acetyl group is removed out and it is taken to the coenzyme A, and the lipoic acid, this reaction, that acetyl group is transferred by the dihydrolipoyl transacetylase. Now the acetyl coenzyme is formed, it's going to attach with the lipoic acid, that is the, it's containing the lipoic acid. So lipoic acid, when you see lipoic acid, the SH and the S means SH, its valency is complete, as the H hydrogen bond is there, and S means with the S, or the, we can say that the sulfide bond is there between the acetyl coenzyme and the lipoic acid. Now as you know, I think when a reaction is happen, the substrate and enzymes complex is formed, then the enzyme is come out and the product we get it, and the enzymes utilize a lot of time. So lipoic acid is there and we need acetyl coenzyme for the reaction. Here is the two molecules you can mention there. There are the two molecules of the acetyl coenzyme. So lipoic acid, we need acetyl coenzyme that is released out. This is the third step. The releasing out of the acetyl coenzyme is the third step, where the formation of the acetyl coenzyme is the second step. You have to know the enzymes involved in it, that makes you simpler. The acetyl coenzyme is removed out. Now the lipoic acid, it is present in the reduced form, SH and SH. Hydrogen is present, means it is in the reduced form. Now the action of the third enzyme is going to come there. We need to reoxidize it. We need to make the enzymes available for the next pyruvate molecule. That's why these steps are added. Lipoic acid SH, it is in the reduced form. Now the third enzyme, dihydrolipoyl dehydrogenase. Dehydrogenase means hydrogen is removing out, so reoxidation is occurring there. So in this, FAD is converting into the FADH2. Here are also the two one. So FAD is going to convert into the FADH2. The electrons is taken by the, or the hydrogen is taken by the FAD to make the FADH2. Now this is not the end of the pyruvate oxidation. What is going to happen? These two hydrogens are going to take by the NAD positive and converted into the NADH. That is the fifth step. That's why you see that the finally we get the 2 NADH and we get the 5 ATP from this step. And the reoxidation of the lipoic acid is going to reoxidize SS. There is no hydrogen is present. So this is the complete phenomena of the pyruvate oxidation. Let's revise the things once more. From the glycolysis, we are getting two pyruvate molecules. CO2 is removed in the presence of enzyme pyruvate dehydrogenase, and as the coenzyme is there, thiamine pyrophosphate, we are going to get the 2-hydroxyethyl thiamine pyrophosphate. Now, from this 2-hydroxyethyl thiamine pyrophosphate, acetyl group is going to transfer. That is the second step, and it's transferred to the coenzyme, that is an coenzyme A of the enzyme E2, and lipoic acid is going to attach. It is a semi-reduced form, we can say that SH and the S. Now, what we need here? We need our product, that is the two molecules of acetyl coenzyme. So, two molecules of acetyl coenzyme is released out. What is the remaining? The lipoic acid is remain in the reduced form. Now, what we have to do? We generally the lipoic acid we want to get in the similar form as it is present at this place before getting attached to the acetyl coenzyme. So the lipoic acid in the reduced form, and we have to oxidize this, and the enzyme is there is the dihydrolipolyl dehydrogenase. The E3 is there. So 2 FAD positive getting the 2 hydrogen. So it's make the FADH2. Two molecules is there of FADH2. Now from the FADH2, 2 hydrogen is taken by the NAD positive, making the 2 NADH molecules. We are getting it there. So this is the finally what we get, and the enzyme that's is catalyzing this reaction is going to involve or excluded out in their original form on the reoxidation, that is the lipoic acid reoxidize S and S, and all these pathway is happening in the mitochondrial matrix. Important thing to you to note down: the ATPs are getting, the enzymes involved, and these the coenzymes. These are the most important uh, targets for the CSIR that he asked about these enzymes in the 2 marks as well as in the 4 marks. I hope you like the video. In the next video, we are going to talk about the Krebs cycle or the TCA cycles. For your support, press the subscribe button. Thank you so much, and all the best for your CSIR and other examinations.